Building owners and architects are demanding more and more highly loadable and wide-spanned designs. Pre-stressed concrete provides ideal solutions in comparison with non-pre-stressed reinforced concrete. The following film demonstrates the manufacture of precast pre-stressed concrete elements on casting beds. When tensioning before the concrete has hardened, the stressing forces must initially be borne by the casting bed. At each end of the bed, there is a heavy anchorage abutment in the ground in which the anchor posts are embedded. In this way, the high forces are transmitted to the ground. With casting beds, one distinguishes between the tensioning end and the detensioning end. For the pre-stressing reinforcement, high-tensile pre-stressing steel is used. In most cases, it is 7-wire strand. Flat lifting slings should be used for transporting the coils. This prevents injuries which might be caused by chains or steel cables. The coil is inserted in a reel for handling. A mark indicates the exit direction. Before laying out the pre-stressing reinforcement, the detensioning cylinders must be prepared on the detensioning end of the bed. Support sleeves are placed on the extended pistons. These transmit the stressing forces until tension is relieved. The strand is unwound from the coil and pushed into the mold with the help of an electrical strand pushing machine. The feed rate is controlled via push buttons. There is a choice of 2 feed rates. The work is more operator-friendly and easier with radio control. The operator can guide the strands and control the feed rate personally. On the detensioning end, the strands are anchored behind the transverse anchor plate. The strands are then cut off on the tensioning end. The best way to do this is to use a hydraulic steel cutter. The strands can now also be anchored on the tensioning end. With the correct selection and maintenance, Paul anchor grips guarantee secure holding. The strands are then frequently tightened. This facilitates the insertion of further strands and increases the overview in the reinforcing cage. Pre-stressing steel couplers economize on pre-stressing steel if the casting bed is longer than the concrete element produced. Before the actual pre-stressing, all the strands are tightened. The oil pressure required for this is set on the pump unit. As soon as all the strands are drawn in and tightened, the mold can be closed. The pre-stressing operation is started with one of the 2 push buttons in the stressing jack handle. The strand is automatically gripped and tensioned up to the set oil pressure. If the steel elongation is greater than the stressing jack stroke, another stressing operation can be initiated. The elongation is measured and recorded for checking. When all strands are tensioned, protection devices are applied. The concrete element can now be cast. As soon as the concrete has reached the specified strength, detensioning can take place. To do this, oil is pumped into the detensioning cylinders on the detensioning side. The support sleeves are removed and the drain valves opened. The pistons are pressed back into the cylinders by the stressing force. The strands are cut off with an hydraulic steel cutter or an abrasive cutter. The finished concrete element is lifted out of the mold and taken away. The necessary stressing force is produced by means of the pre-stressing machine, consisting of a stressing jack and a hydraulic pump unit. The stressing force must be accurately reproducible and measured. A 6-monthly inspection of the pre-stressing machine is therefore stipulated. First of all, a comparison is carried out between the tensioning manometer and the control manometer. A calibrated measuring device is used for the inspection. It consists of the force transducer and the display unit. 3 series of measurements are made at different piston settings. Loading is in 50 bar steps. At each loading step, the manometer reading in bar and the force measurement reading in kilonewtons are noted. After the results are evaluated, a test certificate is issued. A stressing force diagram is drawn after a successful inspection. The oil pressure will then be set according to these values. Short pre-stressed concrete elements are frequently manufactured in stress-resisting molds. A stress-resisting mold bears the stressing forces from the time of tensioning to detensioning. In the case of small elements, the exact introduction of the stressing force places high demands on the pre-stressing equipment and technique. The exact introduction of the stressing force is achieved with a screw-type stressing jack. With this stressing system, pull-in losses are practically eliminated. First, the stressing jack is automatically screwed onto the stressing spindle. The tensioning anchor, including anchor nut, is fastened to the stressing spindle. The screwing on and off operations are controlled electrically. Tensioning now takes place, and the anchor nut is screwed firmly against the mold. Thereafter, the stressing jack is screwed off the stressing spindle. Posts from 2.2 meters in length can be manufactured with the screw jack shown. The posts are used by the German railway in signal engineering.